APPVILLIE Software's Coimbatore. I extend a pleasant welcome to all the attendees to this technical webinar on the topic Industrial IoT for Industry 4.0 organized by our institutional IIoT club. And then I'm very proud to unveil the profile of our today's speaker, phenomenal person for this wonderful session. He is an alumni of PhD College of Technology from the Department of ECE 2006 batch. He started his career as a program analyst at Cognizant Technology Solutions. Then he moved on to Mettler Toledo International Inc. as a senior software engineer for over a period of 9 years. Then he forwarded as a CTO and a co-founder of APPVILLIE Software, Coimbatore. His firm drives towards the dream of combining latest technology to achieve more efficiency in industries. They work across technologies like augmented reality, industrial IoT, machine learning, and Azure Cloud. So let's hear it from our dynamic speaker about Industry 4.0. Thank you, sir, for accepting our invitation. The session is yours. And thank you all.
Okay, thank you. Thanks for the introduction. So, as per the topic, so we will see about Internet of Things industry in the industrial side. And now, so the intro is already given. So what we'll do is basically we'll go run over a history of the industrial revolution, and then we will see why what's the impact of internet. Okay, why internet is needed, how it's going to change the industry, then the impact of IoT, and some bit of technology behind the IoT IoT implementation, and finally the digital twin and the future trend. So this is how we are going to go through this session. Okay, so first looking at the history. So everybody knows this is the Henry Ford. Okay, and so the Henry Ford, as you maybe know, as you know that he's the founder of the Ford company. But before finding the Ford company, he started two companies, but both of them failed. Okay, and the interesting thing is, so usually for before starting that company, he had all the knowledges. Even for the first two companies, he had a very good knowledge about the mechanics, automotive, and the only thing he lacked was the electrical. He did not have the electrical knowledge because that is very important to start a car. Okay, so he joined as a company called Edison, which generates power. Okay, he worked there for one couple of years. Then he understood more about the electricity, and then finally he made a car. Okay, so the problem is he made a car, and the people at that time was ready to invest in this company to start a company. So investment also was also there. Okay, but everything was there, but still the company failed. Okay, so he knows how to make a car, money was there, market was there, but still they failed. The reason of the failure is because they were able to produce in a year only 30 cars, at most 30 cars. Okay, so that is the problem. So how did Ford overcome this problem? Okay, so what happened is, so when they manufacture a car, it usually takes, for example, they first put an engine, okay, then they wait for a steering wheel to come, and then they put steering wheel on top of it. Like that, each part by part, they are trying to fix it. But so they are waiting. The resources are waiting for the next part to come. But at the same time, so he was very frustrated that he was not able to manufacture so many cars. And by chance, he visited a slaughterhouse in Chicago. You know slaughterhouse, right? So they process meat, okay, meat of the cow, or etc. So in there, they were processing thousands of meat every day. So he was very surprised because he is not able to produce a car. He is able to produce only 30 cars a year. But in this slaughterhouse, they are processing several thousand meats every day. So he just went and tried to understand what's the process they are using. So there, what they did was something like a conveyor belt. The meat will be rolling and moving in a conveyor belt. and each person will be processing a certain portion of the meat. Okay, so one person will be processing the neck part, the other person will be the top part, then the middle part, like that. So slowly the entire beef will be disassembled. Okay, so this is the idea that he understood, and that's when the first this thing, the conveyor belt assembly line technology was formed. Okay, by Henry Ford. So he is the father of assembly line, and he is the one who started the industry 3.0. Okay, where the conveyor belts, assembly line, so they were able to mass produce things. So after Henry Ford, every other car manufacturer adopted this. Okay, and the almost because of the process improvement, the cost of the cars came very less. And in US, for example, out of every 3 cars, 1 car would be Ford. So that became very famous, very popular. He made a lot of money. Okay, so that is industry 3.0. And then if you see, they just try to add more sophisticated things, because then they wanted to eliminate this thing like the humans, and they just made it more mechanized. Okay, for example, this is a photo of a Mercedes-Benz plant where a robot assembles many of the parts. So in this example, most of things are done by robot. Okay, even the inspection, the assembly of some components are done. Okay, this is the level of automation done in the industrial side. Okay, but in this there is no internet. Internet is not necessary, because robots, that's the thing, they coordinate with each other. Okay, and there is, for example, there are a lot of communication. Okay, so this is fine. But why we need internet? Okay, so robots are able to do, but still, what is the purpose of internet? That is very important. For example, cameras, right? Everyone have used cameras. In the 90s, there was this normal camera, and then in 2000s, digital camera came. Okay, that was very popular. But only thing is, the whatever photos that we take in the digital camera, okay, we have to copy in a SD card, then put it into PC, and then store it in a hard drive. Okay, this if you notice, some of the photos may be lost unless you are organized. You can't keep you're not organized, you may miss the photos. But now with the internet, okay, you have a phone, you take the photo, every photo is uploaded to the Google Photos or whatever, okay, Facebook or etc. Now the photos are stored. Not only that, we can gain insight from those photos. Okay, for example, this face app, right? By Facebook. So in that app, with your past photos, it can predict how you will look at an older age. Okay. For example, from childhood, say from your age 8 or 9, if you're uploading so many photos. Okay. So the algorithm identify from your when you are 8, say now you are 21. So what is the facial changes that has happened over time? With that knowledge, the ML algorithm is able to predict how you will look after, say, 40 years. Okay, that is possible only because of internet. Okay, this is one of the example. Okay, so just a basic photo, normal photo that we take with the power of internet. So just such a possibility arises. Okay, so is industrial sector. Okay, so where we have a lot of data. Okay, you have things are manufactured. When you connect to internet, you have a lot of data. With that data, we can gain good insights, better insights. That's the core and major reason for advantage in connecting to the internet. Okay. Okay. So fine. So what is IoT? Okay, IoT is like any sensors, okay, any device that you connect to the internet and it has an IP address is called an IoT. Okay. So IoT may be several devices are there. For example, you can use Arduino, Raspberry Pi, or ESP32. Okay, either these devices, whichever you connect to internet, is IoT only. So of this, Raspberry Pi is almost like a computer, like a mini computer. And I think in the latest Raspberry Pi, it also comes with a keyboard, mouse, etc. Okay, so you can just directly plug with some monitor and start using it like a computer. But unlike Raspberry Pi, Arduino is just a microcontroller. Okay, a microcontroller with few other extra components to make your programming bit easier. Okay, than raw microcontrollers. So that is these are devices, but all these can be part of the IoT ecosystem because depending on the application, you may need to use Arduino or Raspberry Pi. Raspberry Pi is very powerful. Okay, it can do a lot of computing. But when it comes to battery life, or you want very, lightweight process to be done, then we can go for Arduino or other microcontrollers. Okay. Okay. So now, before going too technical, I'll just say some examples where IoT has been used and it's very powerful. Okay. And what are the benefits it has given? So in this picture, you can see in Holland. Okay, Holland, dairy business farming is a very big business. Okay, say I think for every 3 humans there is a cow. Okay, there are a lot of cows, and these cows have passport. Okay, they can travel across Europe. Okay, so these are not like normal cows. They can milk up to 35 liters a day. Okay, with proper feed and etc. So they are very this thing very popular and it's a big business. But there was a problem. There is a problem that these farmers faced. The problem is, suppose a cow is pregnant, okay, and during the end of the pregnancy, it is going to deliver the baby. So at that point, at that instant, the mortality rate of the cow was huge. Okay, suppose the cow is about to deliver a baby. Suppose if the physician is there, then it's fine. Then it's the physician can assist the cow, and he can ensure that both the calf and the cow are safer. But it's very difficult to predict when the cow is exactly going to deliver a baby. Okay, that is a big challenge because when it's a small farm, one farmer it's easy to identify, but when it's a large number of cows, it's very difficult to track them. So for that, they are using a sensor called move call calving sensor. Okay, so this is a IoT device, a specialized IoT device. What they do is they connect this sensor to the tail of the cow. Okay, that I mean, as you all know that when the cow wags its tail, okay, usually wags its tail often, but especially during the delivery and when it is exactly going to deliver the calf, the way in which the tail is waved, okay, wagging of tail is very unique, very different. Okay, so what the sensor does, this sensor just detects the tail movement, okay, and sends to the internet. Okay, and there the server tries to compare and understand the pattern of the wagging of tail. When there is exactly, I mean, with the pattern, it can identify when it's exactly going to deliver a baby. At that time, from the server, a trigger is sent to the doctor. Okay, with the location of the cow, details of the location of the cow, and it's going to about to deliver a baby. So in that case, the physician immediately attends the cow and he can take care of the delivery. So this is one simple example, okay, where you can see how IoT is very powerful in saving both the calf and the cow. Okay, so this is one basic example. And yeah, and one more. So, okay, this is for cows. Okay, and also in aquaculture, for example, right, this aquaponics or I mean, where they try to I mean cultivate or what to say farm fishes. Okay, they produce a lot of fishes and a lot of crabs in the pond. So these fishes are very sensitive. Okay, the water quality is very important. Okay, so for example, they should know they should maintain the right pH value. They should also check the right dissolved oxygen, and they should know the TDS content of the water should be optimal. Okay, and the temperature should be maintained. Okay, so these all parameters should be in sync as expected for this species of fish available in the pond. Okay, these should be maintained. Okay, so for maintaining there are so many processes. They add chemicals or food or whatever, but for sensing these parameters, okay, for sensing these parameters, they heavily rely on the IoT system. So where they, for example, they can use a pH sensor. Okay, they can connect it to a Raspberry Pi or some kind of controller, and with that they can push to the cloud and they can monitor the system. This is one more example. So I'm just giving few examples so that you know where these IoTs are being used. System is being used. And medicine. Okay. Medicine also, before the X-rays used to be taken and it will be given to the doctor. Nowadays, these X-rays are in digital form. It goes to the PC, and even before the doctor sees, the computer sees the X-ray and try to understand the symptoms, etc. Okay, and it can make some decisions. Okay, based on the with the ML, with the help of ML algorithm, etc. Okay, and one more company called Bagmo, they also use this IoT heavily. For example, when they separate blood into plasma and blood cells, and these bloods are maintained in a blood bank. Okay, so they attach RFID to that bottle or whatever, and that RFID is tracked across the internet. So suppose they suddenly want B positive or some kind of a rare blood group, say AB negative. So immediately they will know, okay, where, in which place that particular blood is available, because all the details are collected and put in a bottle, and it is pushed to the internet. Okay, so all is available in the server. Okay, so we just saw these basic IoT applications. So suppose if you want to create an IoT thing, okay, IoT system. So we'll see what is necessary, what is required. So they'll be slightly technical for a few more slides. So Raspberry Pi is a very good starting point. So suppose, but if you know some bit of Linux, okay, basic terminal commands, and Python or C, you can go for Raspberry Pi. Raspberry Pi is a low-cost computer. Okay, it also have a desktop version, so you don't have to just go to terminal. So it can boot as a desktop computer, and so everything is miniaturized. So we can use a normal SD card that we use for phone, so that will act as a hard disk, and it has a good RAM capacity, and it's ARM-based processor, like something like our phone processor. Okay, so it is a miniaturized computer. It can be a good starting point. So yeah, so and then IoT, so there is also Arduino. Okay, so when to use Arduino, when to use Raspberry Pi. Okay, so Arduino, Raspberry Pi, like for example, it's like a bike and a car. Okay, Raspberry Pi is like a car. It's very powerful. Okay, it has a lot of facilities in it. But Arduino is like a bike, so it has very lightweight. Okay, so it can be used for less battery consuming kind of process, or lightweight process can be done with Arduino. Okay. So for example, microcontrollers or Arduinos are just 8-bit or 16-bit processors, but whereas Raspberry Pi is a 32-bit or 64-bit, something like our computer. Okay. And Raspberry has a OS, so you can put even Ubuntu also, and there is Windows 10 core. Okay. And there is also Raspbian, Raspbian OS that is provided by the Raspberry Pi company itself. Okay, that is also available. But this microcontroller Arduino does not have any specialized OSs. Okay, so these are just basic. Suppose if you want to work on this thing. So when it comes to programming, so Raspberry Pi has a lot of choices. You can use Python, you can use Java, C purpose. But Arduino, you have to use C. Okay, so but it is not like as tough as embedded C, but it's slightly easier. And Arduino is a low power consuming device, and this is a high power consuming device. Okay, so this is just a OSs that we used in this thing, Raspberry Pi. And apart from these two, now ESP32 is another controller that is heavily being used. Okay, so this is like a non-traditional, like for example, it is basically a Wi-Fi and Bluetooth module. Okay, so it can easily it's a low cost module, so it can connect to Wi-Fi, or if you want to use Bluetooth Low Energy and communicate with a mobile phone. Suppose if you want to do an app, and through the app you want to control a robot, for example, and then this processor can be used as a Bluetooth link, okay, and to connect with that robot, and this also becoming very powerful. And there is also a small processor inside it, so you can also program. Apart from connectivity, you can use for normal programming also. And there is also this Mongoose OS. You can put this OS for inside this controller. Okay. So these are the microcontroller side. Okay, these are devices that is being used for implementing the IoT. Suppose once you get the IoT data, okay, you want to store this data in a cloud. Okay, so that is very important because unless you store the data, you don't get some good insights. Okay, what are the system? So how it was before, how it is now. So if you want to do a comparison or you want to predict something, then the data is very important. Actually, data is the next oil. That's what they say. So that is very critical. So for that, we have a lot of choices. For example, Microsoft Azure. Okay, they provide this IoT hub system, so you can use that, or you can use Amazon Cloud, and these clouds for storing the data. And when you go to Amazon, Microsoft, or any other vendor, they use what they enforce the security very much. Okay, for example, say if you want to connect a Raspberry Pi or a device or Arduino to the Amazon Azure cloud, uh, yeah, in the platform you have to create a certificate. Okay, you have to create a certificate. Only with that certificate the device can connect to the cloud. Okay, so they enforce it from the step one. Okay, they enforce security from the initial part itself. So there is no way that you can connect it unsecurely. Okay, so that is taken care by these platforms. Okay. Okay. Now I will give one more real-time example that we used. Okay, so till now we just discussed about general IoT. Okay, so industrial IoT is a specialized form of IoT where we focus on improving the productivity of the industry. That is our idea. That is industrial IoT. For example, one of our client, okay, in Italy, they produce packing machines, and say for example, per month they produce around 20 to 30 packing machines. And these machines are being exported across the globe. Okay, so they export to Africa or Dubai or US, lots of places. And once they export these machines, once the customer it reaches the customer place and they start using it, there is a lot of I mean they get a lot of queries from the customer like this is not working, the machine is not getting switched on, or it's not spinning. Like this, a lot of complaints they receive. Uh, I mean, because the end customer has very little knowledge about the machine, and these service technicians they travel across the globe and to the customer site, and they understand that the problem may be very silly. Okay, they would have opened some door, some emergency door, and they started the machine. Then the machine will not work. So once they close the door, the machine will automatically work. Okay, so the reason for the problem may be very silly. Okay, or they would have forget to install a tape and they just switched on, and the machine is showing some type of error, and they just insert the tape that the machine gets started. So these kind of very silly mistakes or silly things might happen, but the cost for that silly mistake is very huge. Okay, so because they not close the emergency door, but this guy has to travel across the globe, catch a flight, and he spends 2 or 3 days and goes to the customer side. Then he comes back. Okay, all these are cost. Okay, the traveling cost, the staying cost, and for the 5 days they have to pay for the engineer who has actually visited. That is also very expensive. In Europe, the labor charges are very high. Per day, it will be so many $1,000s. Okay, so these kind of situations arise, and there's a lot of loss in this regard. So they wanted a solution where they want to fix this. So at least the silly mistakes, they want to troubleshoot from their office itself instead of traveling, instead of going to the customer side. So that is when the industrial IoT came into the picture. So all the machines from then, all the machines what they export, okay, has the ability to send the data back to the cloud server. And so these guys, the manufacturing guys, can log into their account and see the health of the device. Okay, they can monitor the health of the device, and they can make decisions. Okay, and the beauty of this solution is now when the customer calls and say the machine is not working, this guy sitting in their office, so under the AC, and he can just log into the computer and see the customer machine and see what error happens, and you can just reply in phone saying that, okay, hey, you close the door and switch on the machine, it'll be okay. Okay, so in that case, so they are able to identify what the error from their sitting in their couch, and they're able to guide their client, and they're able to solve the problem. As simple as that. And this is a phenomenal change because a lot of cost is saved. Okay, and the time is saved. The 5 days they can start and continue their production. They need not stop the machine for any silly mistakes. Okay, this is one basic example of industrial IoT. Okay, and yes, now the upcoming trend is digital twin. Okay, so the IoT is there. Okay, it collects the data, and the cloud we are familiar because this data is stored in the cloud and there's some analysis. So what is twin? What is this digital twin? So this is basically what to say, a virtual copy of a real machine. For example, this was used in very early stages by NASA. So NASA scientists, when they try to send a man to a moon, okay, they try to simulate these things, some of the things in the Earth itself, so that they can try to replicate and try to fix any problem. Okay, so this is one basic example. But digital twin, one of the practical use cases, say everybody knows Boeing, right? Boeing is a flight company. Okay, it manufactures and sells flight. I think Boeing, or I mean, yeah, I think it's Boeing. So that company, every flight they manufacture and sell to the customer. These okay, these component, they have a virtual digital copy of that flight. Okay, so when the flight is traveling, they can visually see different parameters of the flight. Okay, so what is the pressure, what is the heat, okay, produced in the turbine, and okay, so what's the wind speed, etc. There's so many parameters they can monitor for the flight. Okay, so the advantage of this digital twin is, for example, every flight they have a copy of it. So now when the flight comes for maintenance, okay, or there is some kind of repair in the flight and they want to troubleshoot it, they want to fix it, now they can gain a good insight of the flight. For example, the flight traveling to Dubai or Abu Dhabi. Okay, so these are hot areas, and there is lot of sand in the in the air because there is dusty, right? These are some desert conditions, so the sand will be in the air, and that those minute particles will affect the fan turbine and destroy some parts quickly. Okay, so when they fly in desert, some parts get damaged quickly. So, and at the same time, when the flight travels to a very cold countries, say for example, Scandinavia country, they go to Norway or Sweden. So because of the cold temperature, certain other parts may get damaged. Okay, so what happens is these things can be monitored and understood with the help of the twin. Okay, they get the data, they compare the conditions, weather conditions, what kind of environment they are in, and what parts they're that is being affected. So what happens is when they with these data, when they produce a next Boeing for us, for example, Dubai, they can put appropriate parts. They know which part is going to fail, and they can change the material for that flight that is going to be used in Dubai. And for Scandinavia, they can put a better part which was able to withstand the cold temperature conditions of the Scandinavian country. So this is one example. Okay, one example of a twin and how they have a good, better, how they improve the standards of the flight. Okay, and apart from this, I think Siemens is also using this technology. For example, everybody knows this windmill, right? So windmill is like a big fan. It produces, generates electricity with the help of wind energy. But some fans are available in the middle of an ocean. Okay, middle of an ocean or a sea. Okay, not maybe in the ocean, but in middle of a sea or somewhere. So there they have these fans. So when they want to troubleshoot or they want to monitor some conditions, it's very difficult for the engineer to sail to the fan in the middle of water and see the conditions. Very difficult. Okay. So in that cases, what happens is they have in their office for each fan that is running here, they have a digital clone of it in the desktop. Okay. And they can monitor the data from their office itself. They don't have to travel across, and they can monitor and they can do update the program to fix some problems if it is a software problem. That is one more example of the win. Okay, so and like there are so many examples of twin. Okay, and so twin is actually much more. There are much more advanced twin also. Example, now till now we were discussing about only the components, individual machines. Okay, they have a twin and how to monitor their condition, how to improve it. But there are large scale twins. Suppose a chemical plant, a big manufacturing facility. Okay, you want to completely clone the entire industry, entire factory, each component, each machine, each facility. Okay, with all the by putting IoT across the plant. Okay, in the production center, in the packing center. Okay, and everywhere if you are able to, and the raw materials, what's the raw materials, what's the count. Okay, and these all parameters you collect over the cloud, so you have entire data set of the entire machinery. So that is a digital twin of the entire factory. The advantage of this system is, say if once you have a lot of data, okay, a lot of data of this thing, so you can predict, for example, when the machine, so suppose a client has an order, say he wants 10 units of X and X, okay, something. And then with the past data, they can identify the most optimal conditions. So how much raw material they need, okay, and what is the right speed of the machine should operate in, okay, and these things can be suggested, and this ML algorithm will automatically guide them through. Okay, what will be the right amount of raw material, that what will be the optimum speed the machine should operate in, and when can they expect the production, okay, from the output, so that they can commit based on this details. They can commit to the customer, okay, this so and so date it will be ready, and they also know the cost structure, what will be the cost of this thing, and how much they can price for the end customer. So these all things are possible with digital twin. In fact, to the next level, this is something which is existing system. Okay, when you want to clear an existing system and understand for the future work, it's fine. But even if before building a device, okay, even before manufacturing, I mean constructing a manufacturing unit, we can. It is possible to virtually create this entire factory setup, okay, and you can virtually see the production data. Okay, you can feed some raw materials and you can see how it is performing. Okay, so that is the next level. So digital twin is a fast improving area. Okay, and there is a lot of traction and lot of interest in this area. So even before the factory is manufactured, people know how it's going to be and what is going to be the performance. It is going to be good, bad, or what changes need to be done. So they can simulate everything before. Okay, so it's something like in software we code, right? We run the code and try to fix the problem or something like that. It's more like the entire hardware machine is going to be like a software. Okay, so everything you can simulate in the computer itself. You can see the production or if the machines rightly fit together. Okay, so these things are possible by the digital twin technology. Okay. So yeah, so these are the things just I just wanted to cover in this session. So let me know if you have any doubts. I think it is you understood something of it. So let me know your doubts.
Thank you, sir, for your informative speech. Okay, guys, do you have any questions? If yes, you can unmute yourself and ask your queries, or you can drop your messages in chat box.
Okay, I think all are clear with the concept. So
Guys, do you have any queries? Post in the chat box or else you can unmute your mic. Really, it was very an insightful session regarding various applications of IoT, sir. And even you made us to visualize and gave an on-field experience about the usage of IoT in various fields. Really, it was a very brainstorming one, and even no regarding the cloud-backed IoT devices and also the digital twin technology. It's a very it was a thing no which we have not yet touched on that part. So it was very insightful and an informative session too, sir.
oh, thank you, madam. Yes, digital twin is gaining more traction now, ma'am. So
Okay.
I think a lot of companies are interested in it, and so it's going to be future. Okay, so it's basically a combination of IoT, machine learning, okay, and AR and those kind of stuff. Yes.
Really, your explanation gave us an on-field experience, sir, because IoT in various applications, right? So, so I think the students have got some spark regarding so that they can move up with their pre-final year projects with all the things you have pointed out in the slides.
Sure, madam. Sure, madam. Thank you.
So one question from my part.
Yes.
What are the requirements you post on a fresher to get into a company who's dealing with augmented reality, machine learning, and the digital twin technologies and all?
Okay, ma'am. So, for example, I mean, because fresher students, so company may not expect so much, but at least they should have a basic understanding. Okay. So, for example, this AR is a very new form of technology. Like, for example, our traditional Java programming, when you develop an app or website, that's different. Okay. You do some programming, you run it, compile it, and it's going to launch the application. But AR is a different ball game. Okay, so there is a lot of animation things. You have to understand a basic understanding of the 3D things. Okay, and you have to combine. You should know how to combine the coding with the 3D stuff. Okay, so that is a very new setup. So definitely they should try to do hands-on because we have been using this AR for nearly 4 5 years. Okay, so we are working on several AR. So we are using cloud AR, cloud-based AR that is very advanced, and we have used model-based AR, and AR there is a lot of steps. So those things they have to try. They have to do some samples to understand what it is. Okay. So that on that part and machine learning, I think students have a lot of awareness nowadays regarding ML. So on the ML also there is some face recognition on body pose recognition, handwriting. So there are a lot of things, but at least they can choose their choice. Okay, for some maybe they like more of a text recognition ML, or some they may be interested in image processing, or some for data. So whatever they're interested in or curious, they can just try to learn that. And the best option will be using GitHub. GitHub there is a lot of repositories. Okay, open source, you can see the cloud, I mean see the code, and they can try to run on their platform. So that is there. So I think students should actually try some, out of curiosity they should learn something, they should try something, so that they can be prepared for the industrial this thing. Yeah.
Sure, sir. Sure. Yes, sir.
And if needed, we can train, because we also give training on AR and other stuffs.
Do you
So
provide
sure.
internships, sir, for the final year students?
Internship, yes, yes, madam. If we have interview rounds, technical interviews, if they clear those things, and if they're technically strong, yes, we give internship opportunities.
Okay, sir. So hope some of our students will be joining your intern schedule, sir.
Sure, madam. Let us see. Thank you.
Yes, sir. Yeah. Thank you, sir. Thank you for the opportunity, sir. Sibi, you can go with the word of thanks.
Hello everyone, good evening to all. It gives me an immense pleasure to deliver the vote of thanks for this event. To all the participants assembled here, I would like to thank our chief guest Mr. Nallaperumal Thanthondri sir, who honored this webinar with his inspirational intelligence in spite of his busy schedule. I would like to thank our beloved principal sir, all department heads, faculty members, and my dear students and friends for making this webinar a grand success. Once again, I thank one and all present here. Thank you, ma'am.
Thank you, everyone. Thank you for attending the session. Have a nice day, guys.